object-oriented programming system and principles. The four major OOPS principles to make scalable and manageable applications are encapsulation, polymorphism, inheritance, and abstraction. Let us have a brief introduction on OOPS principles, followed by a detailed discussion on each of them in the upcoming sections. Click on each principle to know what it is. Just like a capsule that encapsulates combinations of medicines, encapsulation here in Java means wrapping or binding up data, that is member variables, and code, that is methods, together into a single unit called class for restricted access and data privacy. One of the real-life example we can relate it to is the class car that binds up the data members, that is model, engine, etc., and methods, that is driving, braking, etc., together, as you can see in the image. Polymorphism. Polymorphism is the ability of an object to take different forms similar to on and off button in your smartphone. Similar to the button that takes two different forms based on the user's need, Java allows to define different functionalities or methods with same name. In other words, polymorphism empowers the programmer to use same name for methods which have different definitions. One of the real-life example of polymorphism is a cab or a car service provider who can provide different cars with different features as per your requirement. Inheritance. When an object acquires all the attributes and behaviors of its parent object, it is known as inheritance. Inheritance ensures code reuse and controls redundancy. One of the real-life examples is all different types of cars acquire the common attributes like number of wheels, steering, and common behavior like drive and brake from class car, which is the parent class here. A detailed explanation of inheritance will be provided in the upcoming section. Abstraction. Abstraction is hiding the internal details of an object and showing only core functionality that is necessary for the end user. As internal details are generally hidden, abstraction reduces the complexity of the object itself, as we see in the image. For example, when a customer buys a new car, he is not told about each and every detail that is known to an automobile engineer, such as code control of the car, embedded chip used in the car steering, etc. Whereas they are usually told about the features which he or she should know from the viewpoint of driving and safety, such as the engine capacity, fuel consumption, mileage, etc. No internal parts of the car are shown or explained to the customer. We will discuss abstraction in detail in the next topic.